Pervasive computing, also called ubiquitous computing, is the growing trend of embedding computational capability, generally in the form of microprocessors, into every objects, make them effectively communicate and perform useful tasks in a way that minimize the end users need to interact with computers. As computers, pervasive computing devices are network connected and constantly available. Unlike desktop computing, pervasive computing can occur with any device at any time, in any place, in any data format, across any network, and can hand tasks from one computer to another as, for example, a user moves from his car to his office. Pervasive computing devices have evolved to include laptops, netbooks, smartphones, tablets, wearable devices, and sensors. For example, an fleet management and pipeline components, lighting systems, appliances. Often considered a successor to mobile computing, ubiquitous computing generally involves wireless communication and networking technologies, mobile devices, embedded systems, wearable computers, radio frequency ID, tags, and software agents. Internet capabilities and artificial intelligence are often also included. Pervasive computing applications have been designed for consumer use and to help people do their job. An example of pervasive computing is an Apple Watch that alerts the user to phone call and allows the call to be completed through the watch. An environment in which devices present everywhere are capable of some form of computing can be considered a ubiquitous computing environment. Industries spending money on research and development for ubiquitous computing included the following: energy, entertainment, healthcare, logistics, military. Because pervasive computing systems are capable of collecting, processing, and communicating data, they can adapt to the data's context and activity. That means, in essence, a network that can understand its surroundings and improve the human experience and quality of life. Ubiquitous computing was the first pioneer at the Alveti Research Laboratory in Cambridge, England, where the activity badge, a clip on a computer the size of employee ID card, was created, enabling the company to track the location of people in a building as well as the objects to which they were attached. This diagram of pervasive computing shows the role of sensors and other low power embedded devices in pervasive computing. If you see in the chart of pervasive computing, ubiquitous mobility, sensors, embedded computing, low cost, low power, connectivity, lot, smart material and designs, lot applications, multi-devices, experience, pervasive computing applications. The Internet of Things, or IoT, has largely evolved out of pervasive computing through some argue there is little or no difference. IoT is likely more in line with pervasive computing rather than Weiser's original view of ubiquitous computing. Described above, pervasive computing requires less human interaction than a ubiquitous computing environment, where there may be more connected devices, but the interaction and processing of data requires more intervention. Because pervasive computing systems are capable of collecting, processing, and communicating data, they can adapt to the data's context and activity. That means, in essence, that a network that can understand its surroundings and improve the human experience and quality of life. Example of pervasive computing included electronic toll systems on highways, tracking application such as Life 360, which can track the location of the user, the speed at which they are driving, and how much battery life their smartphones has. Apple Watch, Amazon, Echo, smart traffic lights, and Fitbit. What's the future of HCI computer interaction or HCI? What if user interface were no longer trapped within a screen and were instead integrated into your everyday life? Imagine a future where interfaces are personalized to your needs and can appear anywhere. A future where you actually converse with computers rather than poking letters on a screen. Human computer interaction where we are now. There's no doubt that the way we interact with computers has changed drastically over the last decade. And if you're thinking about becoming a UI designer, you're probably especially aware how much smartphones and tablets have paved the way for tons of new and unique interactions between humans and computers. Voice guided user interfaces. Voice interaction is going to go away beyond setting appointments and suffering the web. It's predicted that in the next 5 years, adoption rate of speech recognition will be over 80%. This makes a lot of sense when you consider how much smaller our screens are getting with less screen real estates. Interfaces will become much harder to negative. Virtual augmented reality or VR. With Facebook's purchase of Oculus and Microsoft entering the VR arena with HoloLens, the competition is really starting to heat up. This headset might eventually wither TVs obsolete. After all, why would you watch your favorite football team through a rectangle box when you could have them project into your living room? This is all great news for designers. This technology will come with a completely new set of human computer interaction. Wearables. The Apple Watch has already introduced some really unique interactions like the digital crown and the ability to view another person's pulse. In the coming decade, these devices will become cheaper, more functional, and less dependent on your phone, which will in turn make them far more adaptable. Conclusion. It might be the Wild West when it comes to voice, VR, and wearables, but these technologies aren't going anywhere. In fact, they are laying the foundation for a future where humans and computers are tied more closely together than ever before. Accessibility basically means that people with disabilities can use a product more specifically. Accessibility is making user interfaces pervasive, operable, and understandable for people with a wide range of abilities. Accessibility related to usability. Accessibility has a technical component and a user interfaces component. Accessibility of user interfaces can be approached through usability international organization for standardization defines usability as the extended to which product can be used by specified users to achieve specified goals effectively, efficiently, and with satisfaction. in a specified context of use. What is accessibility? Accessibility basically means that people with disabilities can be used a product. More specifically, accessibility is making user interfaces perceivable, operable, and understandable. For people with a wide range of abilities, accessibility also makes a product more usable by people in a wide range in situations or ideas. What is user-centered design? User-centered design or UCD is a user interface design process that focuses on usability goals, user characteristics, environment, tasks, and workflow. In design of an interface flows a series of well-defined methods and techniques for analysis, design, and evaluation of mainstream hardware, software, and web interfaces.